Alright, this video is on complex numbers. So we've talked about real numbers. Real numbers contain rational numbers and irrational numbers. Here are some examples of rational numbers. That just means fractions, positive and negative. And irrational numbers, that means numbers in radicals, that we can't get rid of the radicals. There's also some special irrational numbers like pi. There's another one called e. I didn't list it there, but e is another irrational number. The complex numbers are a bigger set of numbers. The complex numbers contain the real numbers, and the complex numbers also include the set of real numbers as well as numbers that are even roots of negative numbers, like the square root of -6. So the complex numbers has the real numbers, and it has other numbers that are complex, like square root of -6. Here's a definition that we're going to use right now. I just wrote it in symbols to condense it. I is equal to the square root of -1. So when we had problems, or looking at the one we have here, square root of -6, previously we just said no real number. That's it. It's over. Now we're going to work with it. It's going to be called a complex number. Yeah, I know. The story changes, right? Yeah, we're changing the story. And so then another definition that we have is that I squared is equal to -1. So if we take that first one on the left in the left box, if we square both sides, the square will cancel out the square root. So that's why you get I squared equals -1. Okay, so memorize what's in that box. I is equal to the square root of -1, and I squared equals -1. We're going to use it. Okay, a complex number is any number that can be expressed in the form a plus bi, where a and b are real numbers. Okay, so a plus bi. Typically when we have a variable, we put the variable before the constant, but here it's not a variable exactly. We're going to treat it like a variable most of the time, but the I term will always go last. Okay. This is called the standard form of a complex number. The first part, the a, that's the real part, and the b, the second part, that's called the imaginary part. Okay, here's some examples. 7 plus 5i. The 7 is the real part, the 5 is the imaginary part. Or the 2/5 is the real part, and the square root 3 is the imaginary part. Notice that I put the I before the square root 3. I put a note here. The I can be written before or after the radical. If it is written after the radical, just make sure the I does not appear to be under the radical sign. So if you put it to the right of the square root 3, just make sure it's far enough away so that it's not underneath the radical. Okay, if you do write it that way, then the instructor could mark it wrong. All right, I know it seems a little complicated, but it's not that complicated. To add complex numbers, we're going to add the real parts, add the imaginary parts, and then put it in standard form. Okay, so you might want to take a minute and write that down. I don't think you need to actually. So here's example 1. What you're going to do is add the like terms. So add the ones that don't have the I first, which is 4 and 6. So if you add 4 and 6, what do you get? Right, you get 10. And then add the I terms, 3i and 8i. Right, that's 11i. So our answer is 10 plus 11i. Okay, do the same thing with part B. Add the real parts, the negative 5 plus the 6. That'll be 1. And then the imaginary parts, 3i and negative 5i. So you add negative 3 and negative 5, that'll give you negative 2, and then attach the I. 1 minus 2i. That's it, we're all done. Not too bad, right? So this was adding. What's next? Right, subtracting. It's the same idea. We're going to add the real parts and the imaginary parts. But first, when we have a negative in the middle before parentheses, what do we do when we have a negative in front of the parentheses? That's right, we distribute the negative sign. So we're going to distribute the negative sign and then add the like terms. Okay, here we go. So go ahead and start number 2. Distribute the negative sign and then add like terms. Remember that the I term is last. So if we distribute the negative, we have 7 minus 3i minus 18 plus 5i. And now we could add the real parts, 7 and 18, 7 and negative 18. It's a negative 11. And a negative 3i and a positive 5i plus 2i. All right, next part, distribute the negative sign. And then add the real parts and the imaginary parts. So you should get negative 19 plus 11i. Okay, now we're going to talk about simplifying square roots of negative numbers. Okay, square root of negative 16. So what we're going to do is we're going to use this rule that whenever we have a negative inside, we're going to put an I in front and then take the square root of the positive value that we have left. So here we have the square root of negative 16. So we're going to put an I in front, because really what that is it's the square root of negative 1 times the square root of 16. I probably should have wrote that, but I didn't. Too late now. Now the square root of 16, square root of 16 is 4, and we'll put the 4 in front, so it's 4i. Okay, so we'll do that with the next one. Put an I in front, and then we have square root of 48. So then you just make the inside positive. Now we simplified the square root of 48. You could either do the prime factorization, or you could use a product where one of them is the largest possible perfect square. Either way, you should get 4 square root 3. And now you have a choice. You could put that I at the end or in between. So here are the two ways you could write that. 4i square root 3 or 4 square root 3i. Just make sure the I is not underneath the radical. Okay, do you get the idea? You just put an I in front, and then you get rid of the negative inside the radical. The reason we could do that is because I is equal to the square root of negative 1. So we're separating the problem into the square root of negative 1 times the square root of 38. And then the square root of negative 1 is I. And then the square root of 38, we can't do anything with it, so we're all done with that problem. Okay, so we have the property of square roots, and that says the square root of a times the square root of b is equal to the square root of AB. We did this previously when we were talking about multiplying radicals. Actually, it was the nth root of A times the nth root of B. But we're kind of concerned with square roots right now. The issue is that it's only true if A and B were positive. It is not true if they're both negative. It's actually not true if either one of them are negative. Okay, so what we have to do is we have to simplify it first before we can multiply. So I put two problems here, the same problem actually done differently. And the first one on the left is correct. So let's look at that. Square root of negative 4 times the square root of negative 9. Well, what's the square root of negative 4? That's 2i. And the square root of negative 9, that's 3i. So now we can multiply those. Now what's 2i times 3i? It's 6i squared. You treat it like an exponent. You add the exponent, so I and I gives us I squared. And then we also learned that I squared is equal to negative 1. So we could replace the I squared with negative 1. That gives us 6 times negative 1 equals negative 6. So here's the incorrect method. Square root of negative 4 times the square root of negative 9. If you were to just go ahead and multiply negative 4 times negative 9, see, and that's breaking the rule, that'll give us the square root of positive 36, which is 6. See, we get a different answer. So we have to go by this property that says we can only multiply it if they're positives inside the radical. If there are negatives inside the radical, well, then we have to put the I in front, and then we could make the radicand positive. Okay, so that's what this says. To avoid difficulty with this idea, you should rewrite all expressions of the form the square root of negative b, where b is greater than 0, in the form I square root of b before doing any computations. So you always put the I in front first, and then you can make the inside positive. All right, here we go. So let's look at the first one. Square root of negative 7 times the square root of negative 3. So for each of them, we're going to put an I in front. I square root 7 times I square root 3. You can put a dot in the middle just to separate it. You don't have to. It's whenever you write it all next to each other, then it's assumed multiplication. Okay, so now we could put the i's together. What's I times I? That's I squared. And then square root of 7 times square root of 3 is square root of 21. Now, can we simplify the square root of 21? No, that's it, right? How about I squared? Right. I squared is negative 1. So for our final answer, you don't have to write the 1. Just a negative sign will suffice. So negative square root 21. Okay, part B. Same thing. Put the I in front. You can see this one, there's no dot in between, but it's still multiplication. So the I in front of the 12, the I in front of the square root of negative 3. Now we can put it together. Square root of 36 is 6. I squared is negative 1. And then negative 1 times 6 is negative 6. By the way, you can do these on a calculator. If you have the Casio, when you're using the menu button, if you click on the menu button and then scroll over to number 2, which says complex, and then hit equals, then anything you type, you could type it just the way it looks with a negative inside. It won't give you a math error. If you don't have it in complex mode, it will say math error, but if you have it in complex mode, you could type this directly into your calculator and it'll give you the answer. Okay, let's keep going though. Same thing with part C, I in front of each of them. That gives us I squared square root 12. Simplify the square root of 12. It should give you 2 square root 3. And then the I squared is negative 1, so bring down the negative sign. So the answer is negative 2 square root 3. Okay, one more to go. Put the I in front of each of them. Now we can cancel out the i's. If there's an I on top and an I on the bottom, just like a variable, you could cancel out those i's. So then we're just left with the square root of 6 over the square root of 3. Now you have a couple options. You could actually rationalize it by multiplying the top and bottom by square root of 3. Or you could just put it together as one fraction and then reduce it. That's probably the easiest. So our answer is square root 2. Okay, now we can talk about multiplication of complex numbers. We're going to do the same thing we've done before. We're going to FOIL, we're going to distribute. When we're all done, we're going to replace the I squared with negative 1, simplify it, combine like terms, and don't forget to put the I term last. So express the final result in A plus BI form. Okay, here's our next problem. You might want to pause the video. We're just going to FOIL like we've done before. Okay, so 3 times 5, 15. 3 times 4i is 12i. 2i times 5 is 10i. And 2i times 4i is 8i squared. Now we could add the like terms, the 12i and the 10i, and then replace that I squared with negative 1. Eight times negative 1 is negative 8. And then add the real numbers, the 15 and the negative 8. So that gives us 7 plus 22i. Now we're going to talk about division of complex numbers, which really means fractions. The product of a complex number and its conjugate is always a real number. Remember the word conjugate? We used it when we had radicals, specifically square roots, in the denominator. If we had a denominator of 3 plus square root 5, we would multiply by the conjugate 3 minus square root 5. Well, we're going to do the same thing, because think of it. I is actually a radical. It's a square root of negative 1. So it's the same idea. We don't want to leave a fraction with the I in the denominator. Okay, so the product is always a real number. Here's kind of a proof. A plus BI times A minus BI. If you FOIL it, the middle terms will cancel out. And then I squared is equal to negative 1. That'll give us an end result of A squared plus B squared. Now, since A and B are numbers, real numbers, when you square it, it's still going to be a real number. And when you add them together, it's still going to be a real number. So this gets rid of the radical. It gets rid of the I. So we're going to work on quotients like this, 5i over 3 plus 2i, where the denominator is a complex number. The top also is a complex number, but again, we're very concerned with the denominator. We cannot leave the denominator with a complex number. So our procedure is the same as we did previously. We're going to multiply both numerator and denominator by the conjugate of the denominator to write the quotient in standard form of a complex number. It is also necessary to write a complex number in standard form a plus bi. That's probably redundant to write that, but oh well. Okay, here we go. 4i over 5 plus 2i. So you see what the problem is, right? We have an I in the denominator. So what we're going to do is multiply by the conjugate of the denominator. That's our step one. Multiply the top and bottom by the conjugate of the denominator. The conjugate is exactly the same, but the opposite sign in the middle. So that's 5 minus 2i. Whatever you do the bottom, you got to do the top. So now you're going to distribute on the top and FOIL in the denominator. Okay, that's our result. So if we distribute 4i in the numerator, that gives us 20i minus 8i squared. In the denominator, 5 times 5 is 25. 5 times negative 2i is negative 10i. 2i times 5 is positive 10i, and positive 2i times negative 2i is negative 4i squared. Now, we're going to replace any I squares with negative 1, and then simplify as much as possible. So when we simplify, we can see that the 10 i's, what happens with the 10 i's? Yeah, they cancel. And then replace the I squares with negative 1. So that gives us 20i minus 8 times negative 1 on top, and 25 minus 4 times negative 1 on the bottom. Now we can multiply. 8 times negative 1 is negative 8, but there's already a negative, so that's going to give us a plus 8. 4 times negative 1 is negative 4, but there's already a minus sign, so that gives us a plus 4. We could add the 25 and 4. Notice the denominator. It's the sum of two squares, right? A squared plus b squared. There's no i's left over. So that gives us a 29. Also notice that I put the I second because the I needs to be last. So we have 8 plus 20i over 9. We're almost there. We have one last step. We have to write it in standard form. The standard form is a plus bi. It's not quite that. It's a plus bi on the top, but we have denominator. So what you're going to do is separate it. You're going to put a 29 underneath each term in the numerator. So it's going to be 8 over 29 plus 20 over 29i. That's our last step. If we could reduce in either of those fractions, we would, but neither of those fractions reduce. All right, last example. Again, we have a denominator that contains an I. There is no plus or minus, so we don't have to worry about the conjugate. So what are we going to multiply it by? Many would say 3i, but the 3 is not necessary. We just need to get it an I squared. We just need to get an I squared in the denominator. So we're going to multiply the top and bottom by just I. If you were to multiply the bottom by 3i and the top by 3i, you would still get the same answer. You just have to do a little bit more reducing. Okay, distribute the I on top. That gives us 2i minus 5i squared. Multiply the I on the bottom. 3i times I is 3i squared. Now we're going to replace both I squared with -1. So I squared is -1. I didn't really show it. -5 times -1 gives us a +5. And then in the denominator, I squared is -1. So 3 times -1 is -3. You know, sometimes I'm a step skipper, right? Sorry. Okay, almost there. We need to rewrite it. We need to rearrange it. We're going to put them both over -3. And we have to put the I term last. So first, I put it both over -3. And then whenever you have a negative in the denominator, you usually write that negative in the middle of the fraction. Okay, and then we're going to rearrange it. So the 5/3 is going to be written first. That's negative. And then the 2/3 is going to be written second. That's also going to be negative. Move that negative to the middle. And typically we will put the I in the middle. It's not wrong if you keep it on top next to the 2. But usually when it's a fraction, we put it right in the middle. Kind of like when we were graphing, you know, y equals 2/3 x plus 4. We would put the x right in the middle of the fraction after the slope. I know, all these things to remember, right? Okay, that's it. I'll see you here for the next video. Have a good one.